evening all of you. My name is M.P. Parvez. Today we will discuss about magnetic field due to current carrying wire. Magnetic field. Magnetic field due to current carrying wire. Okay. So actually scientists observed that if a current is passing through any wire, so this makes a magnet. Okay, means behavior of a current carrying wire looks like a magnet. Okay, so suppose this is wire and current I passing through this wire, so this behavior like a magnet. Okay, so magnetic field produced here. So suppose this is wire and I current passing through this. So what is the direction of magnetic field? For calculating direction of magnetic field, we have right hand thumb rule. For calculating the direction of magnetic field, we have right hand thumb rule. Right hand thumb rule. Right hand thumb rule. Okay. It is also known as right hand thumb rule. RST. So actually, according to right hand thumb rule, first we put our thumb in the direction of current and remaining fingers means curl indicates the direction of magnetic field. Suppose this is wire and current passing like this direction. So first we put our thumb in the direction of current and curls indicates the direction of magnetic field. Okay, like this is wire and suppose current is passing through this direction. So first we put our thumb in the direction of current and this remaining finger indicates the direction of magnetic field. Okay, suppose this is wire and current I passing through this wire and suppose this is x axis. Okay, suppose this is x axis. Okay, and suppose this is y axis. Okay, so and current I passing through this wire like this direction. Current I. So first we put our thumb in the direction of current and this direction indicates the direction of magnetic field. So magnetic field in the direction of like this. Okay, and what is this? Actually there are two notation in magnetic field. First is I mentioned here. There are two notation in magnetic field. First, like this type. This indicates outward current. From plane. Okay. Now, second notation is like this. This indicates inward current. Okay, means like inside the plane. Okay, now suppose we have wire and current I passing through this wire. So one scientist name is Biot. Actually Biot is the first scientist. He has given the mathematical relation. Biot He is first scientist he has given the mathematical relation or mathematical formula for calculating the magnetic field at any point in the space. Okay, means actually right hand thumb rule, by using right hand thumb rule we have already indicated we have already discussed that according to right hand thumb rule, first we put our thumb in the direction of current and remaining fingers indicates the direction of magnetic field. Now what is the value of magnetic field at given point? So for calculating the magnetic field value we have Biot-Savart law. Actually Biot-Savart law. Suppose we have wire, current I is passing through wire, and suppose the length of wire is finite. So for applying Biot-Savart law, there are many steps. For applying Biot-Savart law, there are many steps. Okay, so first step is we select a DL element, means small element. We select a small element from given wire, given length of wire. Okay, means we have to select a DL, small element from given length of wire. So suppose the length of wire is finite, suppose 100 meters. Okay, suppose length is 100 meters. So first we have select DL element, small element like DL element. Okay, and now by using Biot-Savart law, suppose this point is given. Okay, this point is given, and we have to calculate the magnetic field at point. Suppose this is point P. This is wire. Suppose length of wire is suppose 100 meters, and current I passing through this wire. So first step, we select D element from given point, given length of wire, and suppose this point is P. Now second step, we connect the point at which we connect the both points, that is first point is DL and second point is at which we have to calculate the magnetic field. That is point P. point P here. Okay. Now, suppose this is wire and current I passing through this wire, and suppose this is point P. At point P, we have to calculate the magnetic field. So first step is, first we select DL element. Now we connect this DL element point to point given. So and name like R vector. And suppose angle subtend is like theta. Okay. So magnetic field due to this DL element, I mentioned here. Magnetic field due to DL element, actually small element equals to dB, and dB equals to mu naught upon 4 pi IDL cross. This is cross. Understand? This is cross. Ideal cross R vector upon R cube. Now this is vector, but this is not vector. Okay. So DL is not vector quantity. DL is here scalar quantity. So for making DL like a vector quantity, we have to multiply by current I. Okay. So I into DL. This is vector quantity. This is vector quantity. Okay. Now this is also vector quantity and this is also vector quantity. Okay. Both are vector. So we know A vector cross V vector equals to magnitude of A into magnitude of B into sine theta. Okay. So actually suppose we have vector A and this is vector B. Okay. So angle subtend like suppose theta. So A cross B is magnitude of A and magnitude of B into angle subtend between both vector. So in current carrying wire, suppose this is current I. Now this is DL. Actually this is IDL. Okay. And this is point P. This is R vector. And this is suppose theta angle. So ideal is also a vector quantity and R is also a vector quantity. If we zoom this DL element, so this like looks like this is ideal and this is R vector and this is angle theta. So both R and vector are like this. So both are vector quantity. So dB equals to mu naught upon 4 pi. dB actually magnetic field due to current carrying wire from small element. Mu naught upon 4 pi IDL cross R upon R cube. Actually I is constant, so we can like take common. So mu naught I upon 4 pi and here DL cross R upon R cube. Okay. Now further dB equals to dB due to this small element and we have to find the magnetic field due to complete wire. So we can integrate this. phi. Okay. Now dl cross r, dl cross r, dl cross r. Actually, this is not vector, but I have multiplied by current I, but I is like constant, so I have to take common. So dl cross r, dl r sin theta. So put here dl cross r, dl r sin theta upon r cube. Now one r is cancelled out here, so here r square. Okay. So finally, integration of dv equals to mu naught I upon 4 pi dl sin theta upon r square. This is the general formula for calculating magnetic field. Okay. Now one question here. Suppose we have finite length of wire is given and current I passing through this wire, and suppose we have this point and we have to calculate, we have to calculate the magnetic field at given point P. Okay. So first we draw a perpendicular from given point. We draw a perpendicular. Okay. So we draw a perpendicular and suppose this angle perpendicular basically 90 degree angle subtend. Okay. Now suppose length is finite. Suppose 100 meters. Okay. Now first step, we selected dl element. So suppose we selected dl element, this is dl. Okay. And if we multiply by I, so this is vector quantity. Okay. Now second step, we connect through this given point and this is r vector, and suppose this is length L. Okay. This is length L. Now suppose this is angle theta. So the end point of wire is, suppose this is first end point and this is second end point. So in third step we have to connect the both end points of this wire through this given point. So first end point is this and second end point is this. And suppose this angle is suppose phi 1 and this angle is suppose phi 2. Okay. Now in this is suppose point C and this is point A and this is point P. So here in triangle ACP, like this is angle 90 and this is angle theta, and suppose this is angle alpha. So this is angle alpha. So 90 plus theta plus alpha equals to 180. Means the sum of angle in triangle is 180. So here theta plus alpha equals to 90. Now this is current I and this is IDA. Okay, and this is point P. Now this is angle theta. Okay, so value of magnetic field is B equals to mu naught I upon 4 pi dl sin theta upon r square. So we integrate this and also here this. So in this question I have this is wire and current I and this is perpendicular distance 90 degree angle, and this is point P, and now length L we have set like idea here, and this is point connect, both point connect. R vector is given. This is angle theta, and this is angle alpha, and this is angle phi 1, and this angle phi 2. So magnetic field is equals to mu naught I upon 4 pi sin theta, sin phi 1 plus sin phi 2. Here, suppose the perpendicular distance is A. So this is the value of magnetic field due to straight wire. Phi 1 and phi 2 is this angle and this angle. Actually, this is the base. So we have take this like minus sign because it is in anti-clockwise. Okay, and this is in clockwise. So first, if we like take minus, so this is plus. So finally, the value of magnetic field is not I upon 4 pi. This is perpendicular distance sin phi 1 plus sin phi 2. Thank you.